Hello everyone. The project we are discussing here is handwritten digit classification. We are going to do this using neural networks. Uh, Very first, we are going to import all the needed libraries for that. We are using Keras here. That's a library under TensorFlow. So we have imported that. Then after we have imported matplotlib as well. That's used to represent or plot the images using Python. And the third one is NumPy. That's a mathematical library which is used to do mathematical calculations, specifically matrices. And in this particular problem, actually, in the data given, uh, the format of data is images. Actually, we are having some images of different digits, either of 0 to 9. So the task is to identify the given image, that what particular number is written on that particular image. So the thing is, there are total 10 digits, so that means total 10 classes of images are there, 0 to 9, and the task is to find out or the classify that the given image out of those 10. So the basic concept here is that each image is made up of pixels, and those pixels are uh, are in the form of a matrix where each block has a value ranging from 0 to 255, and those represent their corresponding colors. 0 means that's the black, and 255 means it's white. So it's kind of image like just like this. Suppose 2 is there, so all the places where white is there, so value more than 2 is more than 0 is written. Suppose this particular corner, so that's not exactly the black one, so some value is there, like 13 is there. So such kind of image is there. So the image is considered as a two-dimensional array, and each of the block corresponding to the image is having a specific value, where all the black blocks are having 0 values, and wherever white is shown at that particular place, corresponding weightage of that uh, pixel is represented up to 255. That's the most accurate white. uh, in in each image there are some length and width. So that's represented as a two-dimensional array. In our given data set, which we have downloaded from Keras also provides data sets. So under MNIST there is this particular data set which we have imported. After importing, we have splitted it into two parts. One is X train and another is Y train, as usually we do in machine learning projects. So the next thing which we have done here is to understand the project, like each of these blocks, actually this is a two-dimensional array. So very first we are going to convert it into a single dimensional array. So here it is 28 by 28 grid, so that will become 784 blocks. That will make up one dimensional array of 784 blocks, because after multiplying this, it will become that large array. And these 784 elements or the blocks will represent individual neuron corresponding to each of the place, and all of these are densely connected to the output ones. Like output set is having total maximum 10 sets are there, like 0 to 9. So each of the set is densely connected with these input neurons, and on the basis of those input neurons, our output will be having 10 options. So out of those 10 options, using sigmoid function, which we are using here in this particular problem, the maximum value, because due to sigmoid function, we get 0 to 1 range. So in this particular problem, we will get 10 options, and out of those 10 options, one which is having highest value of sigmoid function, or the output, will represent the corresponding desired number. So this is the problem explanation. Now let's go to the problem we are solving. So the very first thing which we have done here, we have imported data sets from Keras library, and we have splitted that in two parts. So one is train and another is test. And in the next part, we just researched about the data set. The very first thing is the shape. So here, uh, after checking out the shape, there are 60,000 elements or images in training set, and this 28 and 28 both are related to the dimension of the image. So uh, we are not going to process this directly. We will flatten it, as we discussed in the image already, that this 2 by 2 matrix will be converted into a single matrix, and that will be known as the uh, flattened matrix. So what we have to do, we have to flatten it. But before doing that, we will divide each of the element by 255, so that uh, the particular element can be scaled. In machine learning problems, we usually scale the data elements just for the purpose of accuracy. uh, Next, we reshaped or flattened the data sets, training and test data sets. So we just uh, passed 28 by 28 value, and once we do it, we can check our shape. The new shape which we got is 60,000 784. That particularly means that 60,000 data elements are there in the training set of x variable, and where 784 is the one dimensional array for each of the value. In the next, we can check test flattened x test flattened array, and that's also of 784 array size in a single dimension, and total 10,000 data elements are there in the test flattened array. Now we can check, the data is prepared, so we can check whether this has become in correct format or not. So when we check in x train format of 0th place, so the data element looks like this, which is because of when we divide it by 255, so data elements are now scaled. These are in between the range of 0 to 1. So the next thing is, we just implemented Keras library here, and the sequential function. When we implement sequential function to create our model, the very first thing is how densely these neurons are connected. So total 10 output neurons will be there, and total 784 input neurons will be there. So we have defined that. And how densely are these connected? These are densely connected, sorry, these are densely connected. So each of these 784 neurons will be directly having a reflection or each of the output neurons. And the activation function here given is sigmoid, which is actually used for the output to be in between the range of 0 to 1. And the next one is, we will compile our model, inside of which we have passed optimizer function that's usually used for achieving a higher accuracy or global standards accuracy. Next one is the loss, where we define the function which computes the loss between labels and the predictions, and it depends on output format actually. And the matrices here is the goal of the problem solution, and that's the accuracy. So we are looking for accuracy. In the last step, we are going to fit our model, where we have to pass our training data set, and epochs are actually the number of times we are going to train our data element, to train our neural net model. So we have passed 5 here, so it will run for 5 times. So we can check that in the very first step, its accuracy is 87.72. In the next, it's 91.53, and in the same manner, the latest one, the last one, is 92.55 accuracy is generated by this particular model. To evaluate, we have a function model.evaluate, where we pass our test flattened array with test data in the y. So the returned values can be seen here in this output, and that's same as which we have calculated here, almost same. Now it's time to check the model which we just trained. So here model dot predict is the function to check the values. So in the x test flattened, so in the x test flattened, all the data elements are there which we passed, uh, which we saved for the testing purpose. uh, so we passed the data elements inside this predict method of model, and all the received data, the output will be inside y predicted. But y predicted will receive total 10 elements, out of which we have to find out the maximum value, and that maximum value can be calculated using numpy's argmax method. So suppose at the first place, what value is given, so we can check that. So suppose at the very first place the value given is, if we check, it's given is 2, and uh, in the test data set, we can display that value using matplotlib's matshow function. So if we run that, the value will be printed. That's exact same which we wanted. Yeah, that means our function is working. Suppose we want to check 10th place in the prediction, so that's returning as 0. So let's check in our test value that how it is showing at 10th place which particular image is there. So to view it, we are again using matplotlib's matshow, and yeah, that's, you can see 0th value is there. We can also check for 11th value. Our model is returning at 11th place, value image is 6 digit. So let's check what's there at 11th place, and here exactly the results are matching. That's the model which we just implemented. Thanks for watching.